Welcome back, Physical Science 20. This is the PW2.2 reflection of water waves section. So previous section we looked at reflection in strings and slinkies. Now we look at water waves. So investigate the behavior of waves as they strike parallel, oblique, and curved barriers. Distinguish between the meaning of incident wave ray, angle of incidence, normal reflected wave ray, and angle of reflection, and state the law of reflection. So the first part we have a little bit to discuss here. Then on the flip side, you see I direct you to a YouTube video, and you'll be able to do the assignment while hopefully watching that YouTube video that shows a lot of the water waves in action. Because it's kind of difficult to show you kind of statically what's going on here without looking at waves in motion in terms of water waves. So reflection of waves in two dimensions. A ripple tank can be used to show the properties of two-dimensional waves. A ripple tank contains a thin layer of water. Vibrating boards produced wave pulses, or in the case of figure A right here, traveling waves of water with constant frequency. So you'll have a bird's eye view looking down into the tank and seeing a board continuously hit the water, making waves here. So here you can say these are crests that you see here. And of course they can strike a barrier here and reflect off, as you see in the diagram below. A lamp above the tank produces shadows below the tank that show the locations of the crests of the waves. So yeah, so when you see the wave parts there, we can assume those are all the crests. The wave pulses travel toward a rigid barrier that reflects the wave. The incident wave moves upward and the reflected wave moves to the right. It's hard to see on this diagram, but you have the waves coming up, and when they're hitting this barrier here, they're reflecting off like that. So it's kind of redrawn over here. The direction of the wave motion can be modeled by a ray diagram. And figure B below right shows the ray diagram for the waves in the ripple tank. The ray representing the incident wave is the arrow pointing upwards. So we have our waves right here, our crests. So you can imagine this pencil as the waves coming up like this. So to show that they're moving upwards, we draw an arrow perpendicular to those waves, and that is referred to as the incident ray. So it's an arrow that shows the direction of the wave crests. Okay, the ray representing the reflected wave points to the right. So the waves come up this way, and then they reflect off, and you can see they're moving this way. So the reflected ray shows the direction that the reflected waves go, because you can see the waves here lined up with the pencil. And that is also drawn perpendicular to the waves themselves. The direction of the barrier also shown by a line which is drawn at a right angle or perpendicular to the barrier, called the normal. So here we have the normal here, and it is, so if this is my barrier, the normal is drawn perpendicular. So you can see here we have an angle of incidence and an angle of reflection. Let's take a look at more here. So that's the normal. The angle between the incident ray and the normal is called the angle of incidence. And the angle between the normal and, this should be the, not them reflected ray, is called the angle of reflection. The law of reflection says that these two angles are equal. So the angle of incidence is equal to the angle of reflection. So if you take a look here, maybe let's just do this. So angle right here, that should be angle I, which is angle of incidence. And over here, theta r is angle of reflection. So 5 things on there. So you have your waves, your incoming waves and your outgoing waves, your reflected waves. The incident ray shows the way in which the incident waves are coming in. The reflected ray shows how the reflected waves are exiting. And then you have the angle of incidence, an angle of reflection, which correspond to the angle, the incident ray and the normal. And you have the reflected ray and the normal, that angle there. And we see here that the law of reflection states that this angle is equal to this angle. If you've played pool before, you of course know that if you hit a ball here, it bounces off like that. All right, so over here, this link here, you can copy this link and paste it on Google, and it'll take you to a YouTube video, which will run through a bunch of different scenarios dealing with water wave reflection. And as you're watching it, take out the assignment, and you should be able to answer the questions with the assignment. If you need help, just look at the answer key to see kind of what I'm looking for with some of those diagrams, because some of them may be difficult to see. So you could look at all of those at once, and hopefully you can get all of the reflection scenarios that are posted in this video. All right, we'll see you again.